So today we're going to be talking about systems of linear inequalities in two variables. I'm going to start out with a little scenario. Yesterday we said, okay, what happens if you go to, and you don't need to write this down, I just want you to listen to this. What happens if you go to the store and you're buying candy canes? And they cost $1. And every little stick of asparagus, because it's so delicious, costs $2. And we said you only have $10 to spend. Well, yesterday we came up with the equation if x represented number of candy canes and y represented number of asparagus, and we said you have $10 to spend. Well, that meant that 1 times x plus 2 times y had to be less than or equal to 10. Well, now let's say you have another situation here. And you're going to the store and you're buying this candy canes, this asparagus for your family, and you have 4 family members you have to buy for. So we're going to add this in. You have $10 to spend, and you have 4 family members. So everybody needs at least 1 candy cane or 1 asparagus. If you show up with just 2 things, somebody's going to be mad. So what that means is you now have another equation. So the number of candy canes and the number of asparagus total have to be at least 4. You can buy extra, but you have to have at least 1 for each family member. So now we have a system. We know that x plus y also has to be greater than or equal to 4. So we start thinking about the points that work here, and in order for a coordinate to be a solution to this problem, it has to work in both equations. It has to satisfy both inequalities. So I could buy, for example, 2 candy canes and 3 asparagus. 2 times 1 plus 3 times 2, so that's 8. 8 is less than or equal to 10, and 2 plus 3 is 5, which is greater than or equal to 4. So check. This satisfies both inequalities. So when you have 2 equations like this, or inequalities like this, a solution has to satisfy both of them. It has to work in the first and it has to work in the second. So here's where you want to start taking notes. So I'm going to title my notes Systems, let me have a page in here. Systems of linear inequalities in 2 variables. And the first thing we're going to define is a solution. So a solution to one of these systems is a point that satisfies both inequalities. And I'm going to say satisfies means that it works in it. It makes a true statement. So a point that satisfies both inequalities. So let's look at some examples here. So first example, is, actually I don't really want to do that as my first example. I kind of want to do, okay, let's do this as our first example. Let's say 1x plus 2y is less than or equal to 10, and x plus y is greater than or equal to 4. So this was our example from the asparagus and candy cane thing. So remember from yesterday, step 1 is to graph your inequality as if it were an equality. So graph as if it were an equality. So I'm going to do the first one first. So I'm going to say x plus 2y equals 10. Subtract the x, divide by 2, and I get y equals negative 1/2 x plus 5. So I come over here, I'm going to graph that. Start at 5, 1, 2, 3, 4, 5, down 1 over 2. And before actually drawing my line, step 2 is decide if dotted or solid. Now I know that this is going to be a solid line because, thinking back to yesterday, dotted lines are less than or greater than. This has a less than or equal to, so that means that it's going to be a solid line. So I'm going to draw in my solid line here. Step 3 is to shade. So I'm going to pick a test point. Remember that your test point cannot lie on the line. I'm going to use 0, 0. So I'm going to say 1 times 0 plus 2 times 0 is less than or equal to 10. Well, that gives me 0 is less than or equal to 10. And this is true. So thinking back to your notes yesterday, that means I shade the side with my test point. Well, here's my test point. So I have to shade the side that includes my test point because that's a solution. So I'm going to shade this in. Now, that's for my first inequality. Well, I also have to graph my second inequality. So I'm going to come over here and I'm going to graph my second inequality. Graph as if it were an equality. So x plus y equals 4. Subtract my x, I get y equals negative x plus 4. So I start at 4, 2, 3, 4. And I go down 1 over 1. And now I have to decide if it's dotted or solid. Well, it's going to be solid again because it's an or equal to. So I connect. Ooh, kind of a bad connect, but there we go. And now I'm going to do my test point to decide where I have to shade. So I'm going to pick 0, 0 again because it's not on the line. So 0 plus 0 is greater than or equal to 4. 0 is greater than or equal to 4. This is false. So what that means is that here's my 0, 0. I want to shade the side that does not contain that point. So I'm going to shade all of this up here. Okay, all of that's shaded in. And remember that all of this part here under the blue line, remember that was shaded yellow. All of that region was shaded yellow. So my question now is, where are the points that satisfy both inequalities? So to figure that out, those are the points that are part of both shaded regions. So those are the points that are part of the blue region and the yellow region, which in my picture turned them green. So my final solution, which I'm going to shade in black, is this area here. And what you need to do when you're doing your homework is you need to darken this area in, or you need to specify somehow that this is your final solution set. So the solution to the inequality, and this would be step 4 here. Let me write this as step 4. Darken area where both shaded regions overlap. Okay, now if you understand this, then you're good to go. You can go try your homework, but I'll do a couple more examples for you guys that want a little more practice. So here's another example. X is greater than -3. So first I'm going to graph it as if we're in equality. X equals -3. Remember, that's a vertical line, and it's going to be dotted. So here's this. Now greater than -3. All the points where x is greater than -3 are going to be shaded to the right. I can use a test point if I want to. I could pick 0, 0. 0 is greater than -3, true. And so I shade to the right. Either way, I know that I'm going to have to shade to the right. So shading to the right is all of this over here. All right, now my second graph that's okay.
Shut the door.
All right, so the second line here, I'm going to graph it as if we're in equality. So 2x minus 5y equals 20. So I get -5y equals -2x plus 20. Divide by -5, and I get y equals 2 over 5x minus 4. So I'm going to come over here. I'm going to plot my -4 y-intercept up to 1, 2, 3, 4, 5. This is going to be a solid line because of the or equal to. And now I'm just going to connect these. Now I have to decide where to shade. Well, I have to pick a point that's not on the line, so I'm going to pick 0, 0. I'm going to substitute it. 2 times 0 minus 5 times 0 is less than or equal to 20. Excuse me. So now what I'm going to do, I've got 0 minus 0, just 0. 0 is less than or equal to 20. This is true. So I'm going to shade the side of my line that contains that test point. So I'm going to shade above here. So all of this gets shaded in. So now, the last thing we do is darken the overlap, because that's the set of points that satisfy both inequalities. So my final solution is going to be this part here, where my blue and my yellow overlapped. Remember, you need to darken that in somehow on your paper. all of these points satisfy both inequalities. All right, last but not least, if you want one more example, here it comes. So here we have 3 inequalities, so all of our points have to satisfy all 3 inequalities. So first step is to graph as if it were an equality, so x plus 4y equals -8. I'm going to subtract my x, divide by 4, so I get y equals -1/4 x minus 2. I'm going to graph that, -2, down 1, 1, 2, 3, 4 over 4, and that's going to be a dotted line because there's no or equal to underneath. So step 2, I know it's dotted. Step 3, my test point. Again, 0, 0 is not on the line, so I'm going to pick 0, 0 for my test point. So 0 plus 4 times 0 is greater than -8. That gives me 0 is greater than -8, which is true. So here's my test point. Because it came out true, when I substitute it in, I know that I want to shade that side that contains the test point. So I'm going to shade it all over here. All right, now we have the next one. Do this one in purple. We'll do green again. So we've got y is less than or equal to x. So step 1, make it an equality. Y equals x. So that means my y-intercept is 0. Rise 1, run 1, connect with a solid line this time. And now I need to figure out if I'm going to shade above or below that line. So 3. Let's say, okay, so this time I can't use 0, 0 because 0, 0 is on the line. So I'm going to use 2, 1 for my test point. So I'm going to substitute 2 for x and 1 for y. So 1 is less than or equal to 2. This is true. So I shade the side that contains my test point. Well, here is my test point, 2, 1. So I want to shade the side that contains the test point. So everything over here. All right, and I can see that this green area is where the yellow and the blue overlapped. But on this problem, I have a third inequality. So my third inequality is x is less than 6. So first I graph it as if it were an equality. So it's a vertical line at 6. This is going to be dotted. So it looks like that. And this says x is less than 6. I automatically know that all the points where the x values are less than 6 are those points to the left. I could still plug in a test point if I wanted to use 0, 0. It would be 0 is less than 6, which is true. So I shade the side with the test point. So I'm going to shade everything to the left here. I'm going to make it pink. And it starts to get a little bit confusing because of all the colors on here. So everything to the left I've shaded pink. Now, where do all 3 areas overlap? Well, to the left is pink, above was yellow, below was green. So this solution set, it just so happens that it already kind of filled it in black for me. This area is your solution. This triangle here in the middle, that's where all of them have overlapped. Okay? So hopefully that helps, and go ahead and get started on your homework.